Hi guys, I'm here to explain problem number 9 on the practice assessment. Problem number 9 says use the standard heats of formation to calculate the heat of reaction for the complete combustion of ethane. Ethane is C2H6. So you can see by the equation, the entire equation is 2 moles of C2H6 plus 7 moles of O2 is going to get us 4 moles of CO2 and 6 moles of H2O. In the chart, we have the standard heats of formation, so we can click on that. And that pops up these right there. So that's what I'm talking about, the standard heats of formation. And we have the final answer. So let's do the work in order to see that final answer. So the equation that we use for these problems is delta H of the reaction, which is the standard enthalpy of the reaction, is going to be equal to the sum of the products, the standard heat of formation for the products, which is written H with the little superscript that's a 0. And we're talking about the products here first, minus the sum of the reactants, the standard heat of formation for the reactants. We write that with an H, that little superscript of a 0, and reactants. So our reactants here that we have are going to be the 4 moles of the CO2 plus our 6 moles of the H2O, right? So we're going to add those two together and then subtract them from the reactants, which are the 2 moles of our ethane, which is the C2H6. Add that to our oxygen, which we have 7 moles of that, and O2 is oxygen. Then I go back and I look in the chart to see what the values are. So I'm going to plug in those values and take into consideration those coefficients or those moles, and use that in order to calculate the standard enthalpy of formation for the reaction. So I looked at my table to find the value for carbon dioxide, which is negative 393.5. So I'm going to multiply that by 4. So 4 times negative 393.5. And the units are kilojoules per mole. I forgot my moles right here, so I'm going to write that in right there. So I can eventually cancel out those 4 moles. And this is going to be the first part of this equation. Add that to my second product, which is 6 moles of H2O. So I go back and look at the table, and that's going to be a value of negative 241.8 kilojoules per mole. I'm going to subtract that from the reactant values. So my first reactant is 2 moles of that ethane. So go back to the table, C2H6 is methane, and multiply that by its value, which is negative 84.6 kilojoules per mole. Plus 0, because if I look at the chart, oxygen has a 0 value, right? So anything multiplied by 0 is going to be 0. So we have that, and when I simplify everything out, so get rid of all my moles, multiply those things, add them, and then subtract, my final value is that negative 2,855.6 kilojoules. So that's how we get that problem.